Hello children. So we come back with the topic of sets and Venn diagrams, and here we are going to learn how to illustrate a set on a Venn diagram. Venn diagram, remember, they are something like this. Something like this kind of stuff is Venn diagram. Okay. Suppose you have been given a set and they ask you to illustrate your set on a Venn diagram. Actually, Venn diagram is the best form of illustration of a set where you can find the common elements, complement elements, right? So it becomes very easy. So when you are given a complex question, you always convert that thing into Venn diagrams, and then you can find your responses from that particular Venn diagram. It's very easy. So the first skill requirement is you should be able to convert a set into its Venn diagram. So we are going to learn that part here. Okay. So let's begin with the first question. We have been given the question like this. We have two sets A and B. We have to illustrate on the Venn diagram. In Venn diagram, there is a universal set too. So what is the universal set? 1, 2, 3, 4, 5, 6. And set A has 1, 2, 3, 4 and 3, 4, 5, 6. In such kind of things, see, you look at our sets which are inside the universal set. Okay, universal set will be a rectangle, something like this. This is our universal set. Now it will have so many numbers inside it, right? But there are two sets, A and B. Look at if something is common between A and B. If it is not common, then we will write two different circles. But if there is some common, we will intersect those two circles. Okay. I find that in A and B, 3 and 4 are in both the 3 and 4. These elements are in both the sets. That means the circle should coincide. Okay. So it should be something like this. Okay. Instead of writing circle, if you write oval, you will have a lot of place to write in it. Okay. So because 3 and 4 are common, so name the set A and B. Write 3 and 4 here because they are common in both the sets. Now what are the sets elements of A which are not common? So 1 and 2, I write 1 and 2. So all 1, 2, 3, 4 elements of set A is done. See, they are in the circle of A, right? Then what are in B? 5 and 6 should be there. Now look at the circle of B, 3, 4, 5, 6. So that is also done. Is something, any other element which is not there in this thing but there in a universal set? The universal set has only 6 elements and all 6 elements are included. So there is nothing which is outside the circle, nothing has to be written. So our task is completed. Okay. So A we have done. So I want you to pause this video and copy this. Then I'll erase this and do B. Okay. I hope you have copied this one. Now let's do B. So straight away go for a rectangle. This is our universal set, mark as U. Okay. Now look at A and B. Do you find anything common? Yes. 9 I find at both the places. 6 also is there. 6, 9. 6 and 9 are there. And then here you have 7 and you have 10. So that's definitely, once again we are going to draw two circles which intersect each other. This is set A, this is set B. What is common? 6 and 9. 6 and 9 are in both. So see, A also has 6, 9. B also has 6, 9. Now what are things which are here? 7 and 10 for A, and for B 5 and 8. Now universal set has some numbers. How many numbers it has? 4 plus 3, 7. Only 6 are here. Which number is not included in A and B? 4, isn't it? I don't find 4 here. So 4 should be written outside both the circles. Okay, understood? So this is how we represent a set on Venn diagram. This skill is the most important skill which you should learn, because in exam you will have a word problem, a real-time application criteria D question, where you will be tasked to make a complex Venn diagram and you will have to find results from that particular diagram. So build this skill, okay, using these type of questions in our exercise which is there in examprep.world. Okay. Next question. So instead of elements, it is more of subjective. They have not defined elements. They said universalist triangles, equilateral triangle and isosceles triangle. Now, if you don't know the meaning of equilateral and isosceles, then difficult. Equilateral means all three sides are equal, all three angles are 60 degrees. Isosceles, only two sides are equal and third side is unequal. Okay. Basically, I will write for you. Equilateral triangle will look like this. All sides will be equal and all angles are 60 degrees. These are small information that we expect you to know. And this is equilateral. The meaning is there in the name itself, equilateral, equal sides. Okay. Then isosceles. Isosceles looks like Greek or Latin word. That means two sides are equal and these two angles are also equal. This is an isosceles triangle. Okay. Now, both are triangles only, right? So, universal set, they said triangles. All are equilateral triangle, isosceles triangle? Yes. But not all isosceles triangles are equilateral triangle. So, which is a subset? Triangle, the universal set is triangles. The universal set is all triangles. Then comes, see, all isosceles are not equilateral, but all equilateral are definitely isosceles because two sides are equal. So, this should be I, which is isosceles, and inside this equilateral. Okay. Triangles, all isosceles triangles and all equilateral triangles, right? Because all equilateral triangles are isosceles triangles as well as triangles. You understood the concept, okay? So, this is how we can represent our Venn diagram for part A. Now, let us do part B. Quadrilaterals, any closed shape with four sides, quadra, four, lateral, straight lines. So, any shape with four sides is called a quadrilateral. There are so many kinds, square, rectangle, parallelogram, trapezoid, and kite, rhombus. Okay. So, here they are talking of parallelograms and rectangles. What are parallelograms and difference between parallelogram? Parallelogram is something the opposite sides are parallel. Okay. And what is rectangle? Rectangle is also a parallelogram, but the angles of the rectangles are all 90 degrees. So, these two sides, opposite sides are parallel. So, all rectangles are parallelograms, but all parallelograms are not rectangles. So, now I think you have understood what we should be doing in our set. Draw the rectangle. Universal set is quadrilaterals, quadrilateral. Then comes parallelogram P, which is parallelogram, and then comes rectangle. Okay, easy to understand. So, we have done this question where they wanted us to illustrate this particular case on a Venn diagram. Both A and B we have done. Let us move on to the next question. This question, it will be a little difficult to illustrate on this particular diagram, but still we will try. I will zoom this one because there is less space to write it there. Okay, now I have some space here. I think we can write. X is a number. Universal set is all positive integers from 1 to 30. Everything from 1 to 30 should be there inside this square bracket. But what about A? A is all prime numbers less than 30. Okay. So, let us write A. So, all prime numbers are okay. List of all prime numbers. Let us start writing. 2, 3, 5, 7, 11, 13, 17, 19, 23, 29, 24, 25, 26, 28, 29. Okay. So I have all the prime numbers from 1 to 30. Okay. So A is done. Multiples of 5. 5, 10, 15, 20, 25 and 30. Less than equal to, so include 30 here. Okay. Odd numbers. 1, 3, 5, 7, 9, 11, 13, 15, 17, 19, 21, 23, 25, 27, 29. So we have defined our 3 sets. See, all 3 sets we have defined. Okay. Once you have defined all the 3 sets, we have to see which is the common thing in this area, which numbers are common in all the 3 sets, and that one we will include in this particular common area. Okay. So what are the things which are common? I see 5 is there in all of them. See, 5, 5 and 5. Do you have something else here? No? 5, multiples of 5 not there, and odd numbers. 25, 25 is here in both of them but not here. Okay. So that's it. So we have only one number, which is 5. So we have written in the common area. Now look at what is common between A and B. A and B. That thing we will include in this particular zone between A and B. Okay. So A and B, 5, 5, 15. A and B I am looking. So it's 5. Practically we don't have anything else other than 5. Isn't it? There is nothing else. So between A and B, we only have this particular thing, 5. What about A and C? There should be quite a few of them. A and C. Look at A and C. 3 is there. 5 is already included. So first write 3. The moment we get, then you start writing them. 3. Okay. And then 5 already we have written. 7 we should write here. 7. 3, 7 also included. Then go for 11, 13, 17, 11, 13 and 17. Okay. Then 23 and 29. 23 and 29. So all these elements inside this particular zone are common between A and C. So we have written there. Now what are leftover elements of A which are not there here? I see 2. So I will write 2 here. 3 is done, 5 is done, 7 is done, 11, 13, 17, 19. We got another one, 19. Okay. Oh no, 19 is there in both of them. We can't miss it. We can't write it here. Write 19 here only. 19 stands in both of them. See, 19 is there. And okay. 23 and 29. So practically all elements are covered. All elements of A are covered, right? Now let us also see something common between B and C. B and C. So we will fill this element because this is empty. Nothing is here. Okay. Now let us fill this one. B and C. See what is common between B and C. 5 already is done. Then 15 and 15 is there. 15 and then 25. 15 and 25. Okay. Anything else is there? That's it. So B and C is done. So what are elements of B which are not there here? So 5, 15, 25, 5, 15, 25. So 10, 20 and 30 should be written over here. 10, 20 and 30. So all elements of B also included. Now you just have to plug in values of C which you don't find here in the common area. So it starts with 1, 3 is there, 5 is there, 7 is there, 9 is not there, 9, 11, 13, 15, 17, 19, 21, 21, 21, 21, 21, yes, 21, 23, 25, 27 and 27, and 29 is already here. So we filled the balance elements of C. Now how to check whether we have done things right or wrong? Okay, we have done with a lot of effort we could complete this, but whether it is right or wrong, count the number of total elements. They have to be 30. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. Gone. So we have a trouble. Total element should be 30. So 1, 2, 3. So all other elements we have to write outside things. So we have C4. So 4 has to be written here. 5 is there. 6, 6, 6, 6, 6 not there. So 4, 6, 8 also you don't find anywhere here. 4, 6, 8, 9, 10, 11 done. 12, 12, 12 also not there. 12, 13, 14 is not there. 14, 15 is already included. 16 not there. 17 included. 18 not there. 19 is already there. 20 is there. 21 is here. 22 is not there. 23 is there. 24 is not there. 25 is included. 26 not there. 26, 27 is there. 28 is also not figuring out. Now, how many were there total? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. So, all 30 elements are included in the Venn diagram. So, our Venn diagram is right. So, that's the test. You count all the elements inside the sets and outside the set, right? So, which are in the universal set but not in the ABC. Total should be 30 because universal set has total 30 elements. So, we could do it properly. Oh, great job. So, copy this. I'll zoom out for you guys. So, one step. Okay. Okay, you're back. So, with this, we have finished our type 2 questions of sets and Venn diagrams, and I hope you have understood. In the next video, we will see other types. Thank you. Keep practicing.